Hello everyone, welcome back to our channel Problematical. We were discussing about chapter 2 polynomials from class 9th maths NCERT. We discussed how to divide two polynomial functions using actual division method. Today we will continue our discussion and try to calculate the remainder of when two polynomials are divided without using actual division method. The theorem used in such process is called remainder theorem. Let's see what it means. The theorem so states that if you have p of x, and if you divide this p of x by something, by a linear function, linear polynomial, x minus a. To do this, or after performing this by actual division, you might get q of x and remainder r of x. But instead of actual division, you can get the remainder by substituting this value of a in p of x. That means whatever value of p of a you get in this scenario is your remainder. This is what remainder theorem states. Let's understand this with the help of an example. So let us consider p of x as 2x squared plus 5x plus 7. And your denominator is g of x. So let's consider g of x as x plus 2. Now, if you compare this x plus 2 with this x minus a, you can understand that you're comparing them, which means you're equating them. A will be equal to minus 2. So you can get a is equal to minus 2, and here r of x means you have to calculate p of minus 2. Whatever the value of p of is the value of p of minus 2 is the value of your remainder. So let's calculate it. We are substituting the value of x as minus 2 in the equation of p of x. This is 2 into 4 minus 10 plus 7. 8 minus 3, which is 5. Now, instead of comparing, as we did over here, this is the comparison that we performed. We equated g of x with x minus a. We can also equate g of x with 0. So if you equate g of x with 0, x plus 2 is equals to 0, which means x is equals to minus 2, which means p of minus 2. You still have to calculate the same value. So either you can compare your given g of x with x minus a, or you can equate g of x with 0. Either way, you will get p of minus 2. You will get the value which you have to substitute in place of x to get the remainder of that particular division. Now here g of x is a linear polynomial. What happens if g of x is a quadratic polynomial? In that case, you'll have to convert that quadratic polynomial into factors which are linear in nature. This process is called as factorization, which we will see next. Now, if you have a quadratic polynomial, let's say ax squared plus bx plus c, this quadratic polynomial can be represented as x minus p into x minus q, where p and q are roots or zeros of your ax squared plus bx plus c. X minus p and x minus q are factors of ax squared plus bx plus c, or you can say ax squared plus bx plus c is the multiple of x minus p and x minus q. Both x minus p and x minus q are linear polynomials. So you're representing a quadratic polynomial in terms of linear polynomials. Now, last year we studied a few algebraic identities. Amongst those identities were something as such: x square minus a plus b into x is plus ab is equals to x minus a into x minus b. If you can observe, what's happening here is the x square term has a coefficient 1, x term has a coefficient of minus a plus b, and your constant is ab. A and b are your roots or zeros of your polynomial. Also, let's write it in capital letters so that we can compare. If you compare equation 1 with equation 2, you can see that this p and q are the roots over here. A and b are the roots over here. Here your coefficients are a, b, and c. Here your coefficients are 1, minus a plus b, and ab. You have separate coefficients over here, coefficients which are different than p and q. However, the coefficient in equation 2 are represented in terms of your roots or zeros. Now, with this information in mind, we can calculate the factors by using Middleton splitting method. Let's see, you have question x square minus x minus 12 is equals to 0. Now we know that this is a quadratic polynomial, degree 2. It can be represented in the form x minus a into x minus b. We also know by the previous, this question, by this formula, this one, that the middle term, the coefficient of x, can be represented as the sum of these two with a minus sign over here, which means these two are responsible for addition. Similarly, the constant term can be represented as multiplication of these two, provided your x square has a coefficient 1. So, as we can see, x square has a coefficient 1, which means a plus b is equals to, let's include the minus sign for the time being, minus 1, and a into b has to be equals to minus 12. Your a plus b is minus 1 and your ab is equals to minus 12. You have to find two numbers such that their multiplication is minus 12 and their addition is minus 1. We know 12 can be factorized as 3 and 4. 3 into 4 is 12. But to get a minus sign, you have to apply minus either to 3 or to 4. So let's apply it to 3 first. If you add these two values, if you consider this as a and this as b, and if you add them, a plus b, we will get minus 3 plus 4, which is equals to plus 1. Our required answer is minus 1. So we cannot apply minus sign to 3. So let's see what happens if you apply minus sign to 4. Now your a plus b is equals to 3 minus 4 is equals to minus 4. You can consider 3 and minus 4 to be either of a or b. So let's say this is your a and this is your b. X square. Now what you have to do is take these values and substitute them over here. x square minus 4 and place an x with it, plus 3, place an x with it, minus 12 is equals to 0. We can place a plus sign over here as well. Now in your textbooks last year, this is given as plus sign, but either of the two notations will suffice. So x squared minus 4x plus 3x minus 12. Let's consider them expressions for the time being rather than equations to avoid complication. X can be taken common from first two terms. X minus 4 is the term which is left behind, plus 3 is common amongst these two terms. From the first term, 3 is common, so x is left out, minus sign as it is. From 12, 3 is taken common, so 4 is left out. Now this is your first term and this is your second term. In these two terms, x minus 4 is common. In the first term, x is left out, plus sign. In the second term, 3 is left out. This is your first factor, this is your second factor. If you want to represent it in this form, you can do so. X minus 4, x minus of minus 3. So A is equals to 4 and B is equals to 3 by comparison. Either you can compare, or if you do not want to compare, then you can equate each of these linear polynomials with 0. Now, if you're asked factors, then these are the factors, like these are the required factors. The method that we used is middle term splitting method. You took the middle term, you took the coefficient of it, you observed it, and you split it based on the constant value. So this is splitting the middle term based on your constant value. In the first initial step, you had only one x term. Later on, you had two x terms. That means the x term got split into two values. If the factors are asked, this is your answer. If you're asked roots or zeros or values of x for this quadratic expression, then you can write x minus 4 is equals to 0 by equating the first linear polynomial with 0, x minus of minus 3 or x plus 3, as in the previous case, equals to 0. X is equals to 4 or x is equals to minus 3, which means your first value is 4 and second value is minus 3. If you place either of these values in this equation, your remainder will be 0. Or if I express this as p of x, what we're trying to say is p of 4 will be 0 and p of minus 3 will be 0. Further verifying the fact that 4 and minus 3 are the roots or values or zeros of your p of x, and x minus 4 and x plus 3 are the factors of p of x, which also means you can divide x squared minus x minus 12 by your factor x minus 4. You'll get a quotient q of x, and your r of x will always be 0 because it's a complete factor. Or you can divide x squared minus x minus 12 with x plus 3. Again, you'll get some value of q of x, but your r of x will be equal to 0. So a proper understanding of what you're dealing and why you're writing the way you're writing is a must in these kind of questions. They will be carried forward further in 10th standard as well. So make sure your concepts are crystal clear. Let's take a few examples of this middle term splitting method. If I take x squared plus 7x plus 12 is equals to 12, then let this be another s of x, a polynomial. By middle term splitting method, it states that this value, coefficient of x, is a plus b. So your a plus b is equals to 7 and a into b is equals to 12. Since both are positive, no need to mention that, the signs. So multiplication of two values is 12, but addition of two values is 7. We know that factors of 12 is 3 and 4. Factors of 12 is also 6 and 2. So instead of 7, if you would have had 8, so if in a second quadratic binomial, x square plus 8x plus 12 d of x. In this particular equation, a plus b is 8 and ab is 12. Here ab has to be factorized into 3 and 4 because 3 plus 4 is 7. Here ab has to be factorized into 6 and 2 because 6 into 2 is 12, but 6 plus 2 is 8. So the values of a and b will vary based on the equations that you form. These are the two equations formed from the coefficients of the given polynomial. So x square plus, both signs are plus because you're adding them to get positive 7. So plus 3 times x value plus 4 times x plus 12. Common. Amongst first two, x is common. You're left with x plus 3 plus 4 is common. You're left with x plus 3. First term, second term. Amongst these two terms, x plus 3 is common and you're left with x plus 4. Here, x square plus 6x plus 2x plus 12. This is common. X is common. X plus 6 plus 2 is common. X plus 6. X plus 6 common amongst the two terms and you're left with x plus 2. So we will only calculate up till factors, and the further calculation I've already shown you once. If you want me to repeat it, you can let me know in the comments. Now, let's consider 4 generalized values. If you have ax square plus bx plus c, that means both signs are positive. Your factors will be something like x plus a into x plus b. This is what you'll get, considering a and b both are positives. A and b are positive. And a is greater than b. These are the two assumptions for the assumption for roots of the polynomials that we're attaining. If your ax square, if it is ax square minus bx plus c, since it is minus, your multiplication is positive. Multiplication is positive only when both the values are negative or both the values are positive. That means you can get plus 12 if you multiply minus 3 with minus 4, or if you multiply 3 with 4. That means both the sign of the digits of the numbers have to be the same sign, which means you have to consider either one of them based on your coefficient of x. Now, coefficient of x is negative, which means both values have to be negative, or one value have to be negative and the other one positive, which means both the values are negative. Your factors so obtained will be x minus a, x minus b. Now, if you have something like ax square minus bx minus c, both values are negative. If you have something called minus 12, you need a negative value. 12 can be split into 3 and 4. You'll get a negative value only when the greater number has a negative sign and the smaller number has a positive sign, because multiplication is negative, which means only one has to be negative. Your smaller number is positive, greater number is negative. So your greater number is negative and your smaller number is positive. Last, ax squared plus bx minus c. If you have negative sign over here, minus 12, it means that you need one of the two values to be negative, 3 amongst 3 and 4, but at the same time it's positive. So the greater value has to be positive, which means the smaller by default becomes negative, and your factors are x plus a, greater value is positive, into x minus b. You can use this understanding to verify the answer obtained by you is correct or not, or you can even use it while calculating it, which means your x value will be minus a or minus b. Here a or b, a or minus b, and minus a or b. So you can either memorize it in terms of factors or in terms of values. The a is the greater value and b is the smaller value. Next, the second method to calculate under the heading of factorization is factor theorem. Now, the statement of factor theorem is, if p of x is a polynomial, of degree n such that n is greater than or equals to 1 and a is any real number, then first x minus a is a factor of p of x if and only if p of a is equals to 0, and 2, p of a is equals to 0 if x minus a, let's consider this if rather than if and only if, is a factor of p of x. So this is exactly what we've been studying up till now. Your remainder theorem is a part of this. It states that you have a polynomial p of x and the degree is n greater than or equals to 1. So you've got a positive degree. That means the smallest polynomial under consideration is a constant polynomial, and the value of degree goes on increasing thereby, because the smallest polynomial is a linear polynomial, because you at least have a linear polynomial. A is any real number, and x minus a is a factor of p of x if p of a is equals to 0. Let's consider the second conclusion of factor theorem first. It states that p of a is equals to 0 if x minus a is a factor of p of x. That means if you divide this by x minus a, your remainder will be 0, because we've already studied previously that p of a, the same a, represents your remainder, which means by saying that this value is 0, it states that your remainder equals to 0. So in both the scenarios, let's imagine p of a as your remainder. This is equivalent to r of x. This is equivalent to r of x. So they are saying that whatever value you divide your p of x by, that value is your factor if your remainder is 0, or your remainder is 0 if that value is your factor. That is exactly what we've been studying up till now. Now, how to solve your quadratic expression polynomial? how to calculate the factors by using this factor theorem. So the procedure so says, let us consider y square minus 5y plus 6. We know that this value is equals to a into b, multiplication of your two factors. So the factors of 6, your first step is calculate the factors of your constant in your quadratic polynomial. So 6 has factors as such 1, 2, 3 and 6. Now discard 6, you're left with 3. Either now in the second step, either you can use the observation like this table and understand that it is of the form of this. So definitely your a and b individually are positive values. In terms of factors, it is x minus a and x minus b that you're expecting in your answer. Now, your values can be either plus minus 1, plus minus 2, or plus minus 3. So let's place all these values over here. You'll have to calculate p of, let this be equal to p of x, p of y. We are calculating this on the next page. So given that p of y is equals to y square minus 5y plus 6. In this scenario, the possible values for your roots or zeros or factors are plus minus 1, plus minus 2, and plus minus 3. These are the supposed values of your small e from your theorem. So what you're supposed to do is, you're supposed to calculate p of positive 1, p of minus 1, p of positive 2, p of minus 2, p of 3, and p of minus 3. And that's it. Two of these values should be equal to 0, which means for those two values will be equal to your zeros. P of 1, 1 square minus 5 into 1 plus 6. This is equals to 1 minus 5 plus 6, 7 minus 5, which is equals to 2, not equals to 0. Minus 1, minus 1 square minus 5 into minus 1 plus 6, which is equals to 1 plus 5 plus 6 is equals to 12, not equals to 0. 2 square minus 5 into 2 plus 6 is equals to 4 minus 10 plus 6. 6 plus 4, 10, 10 minus 10 is 0. So this is your first value. Minus 2 whole square minus 5 into minus 2 plus 6 is equals to 4 plus 10 plus 6 is equals to 20, not equals to 0. 3 square minus 5 into 3 plus 6 is equals to 9 minus 15 plus 6 is equals to 0. This is 9 plus 6, 15, minus 15, 0. This is your second value. Now if you calculate for the third value, you'll get an answer which is not equals to 0. Let's calculate it anyway. So minus 3 square minus 5 into minus 3 plus 6, which is equals to 9 plus 15 plus 6 is equals to 30. Now, for these two values, for p of 2 and p of 3, these two values are 0. That means for your a value will be either 2 or your a value is equals to 3. Therefore, the factors in question are x minus 2 and x minus 3 are the factors of p of y. Now, this is the procedure, but but this is not the complete presentation of a question like this. If you're asked to solve it by factor theorem, that we'll see in the examples and exercises of such questions. Apart from this, your text also contains some algebraic identities, an extension to the algebraic identities covered last year. So last year we saw 4 basic identities: x plus y whole square is equals to x square plus 2xy plus y square. X minus y whole square is equals to x square minus 2xy plus y square. X square minus y square is equals to x plus y into x minus y. X plus a into x plus b is equals to x square plus a plus b into x plus ab. Now with this, we are considering positive on over here. So this is positive. So based on this theory, this has to be negative. Now, apart from these, there are four additional formulas introduced this year. X plus y whole cube. This is equals to first term cube plus 3 times first term square, second term, sorry, it has to be x. First term square, second term, plus 3 times first term, second term square, plus y cube. If you can see, from the first term till the last term, the power of x goes on decreasing, x cube, x square, x, and x to the power 0, which is 1. From the first term to last term, power of y keeps on increasing, y to the power 0, y to the power 1, y to the power 2, and y to the power 3. 3 is multiplied in the second and third term, and first and last term has coefficients as 1. If you can observe, x plus y whole square, first and last term has coefficients 1. The power of x goes on decreasing, the power of y goes on increasing. So it follows more or less the same pattern. Now there's a specific way how you represent these kind of algebraic functions or these kind of expansions. These are binomial expansions. You'll study about them in maybe 11th standard. For the time being, you should only remember x plus minus y whole square and x plus minus y whole cube. X minus y whole cube is equals to x cube. Second term is same except for the sign. Now, if you have a minus sign over here, it says that the terms should alternate their signs. That means first term will always have a positive, second term negative, third term positive, fourth term negative. Same thing happens over here. First term positive, second term negative, third term positive. There isn't a fourth term, so we cannot compare over here in this scenario. Another way to memorize this is write the first and last terms first, x square plus y cube, and here x square minus y cube. Now take common. What can you take common between these middle terms? Plus 3xy. What you're left with is x over here and y over here, so x plus y. X plus y whole cube, you have an x plus y, 3xy, and you have x cube plus y cube. Here, your first two terms are as it is. Then from these two, you'll take minus 3x common. Instead of plus 3x, you'll take minus 3x common. If you do that, you're left with x in the first term, minus sign, and then y from the second term. So in x minus y whole cube, in the second form, all signs are negative except for the first coefficient of x cube. And then 3xy is common. You have x minus y because here you have x minus y. This is another way of remembering it. Next, there are two more formulas. Now, these would seem bulky in nature, last two formulas, but they are essential from perspectives that you'll see in further classes. So, x plus y plus z whole square. That means you're taking the square of three terms now, x, y, and z. This is equals to first term square plus second term square plus third term square plus 2 times xy plus 2 times yz plus 2 times xz. So 2 times multiplication of these two, 2 times multiplication of these two, and 2 times multiplication of first and third. Next is x cube plus y cube plus z cube minus 3xyz. This value will be equal to x plus y plus z, first factor, and second factor, x square plus y square plus z square minus xy minus yz minus xz. Now, apart from these, there are two more formulas that you should know about. X cube plus y cube. Now, this value is equals to x plus y, first factor, second factor, x square minus xy plus y square. X cube minus y cube is equals to x minus y in one bracket x square plus xy plus y square. Pay proper attention to the fact that these are different. This value and this value, they are different. Here you have minus xy minus yz minus xz, and here you have plus 2 as the coefficients of these three terms. Similarly, this value and this value, they are different, and this value and this value are different because your xy term has a coefficient minus 1, it has a coefficient minus 2. Here you have plus 1, here you have plus 2. So these are different values. Now that concludes this chapter. Thank you.